You have the prompt. One of the challenges is you want to be able to augment the foundational model with knowledge that didn't exist in the model. This could be because the model was trained a while ago. It could be because your corporate data, you don't want to actually have that integrated into the model. So this knowledge-intensive reasoning is a big topic under modeling. And there's two ways you can think about it that is done, which is one of is called retrieval augmented generation. This is kind of like what Microsoft is selling a lot right now with their customers. So the idea here with retrieval augmented generation is you ask the question and then you augment it with like a book or a couple articles. And these couple articles, you're getting them from some database, okay? And you hear, so you hear things like vector databases. So that's kind of where they're stored. The other one is another pattern which is called React. So what React does is instead of throwing the whole book and telling here's the whole book, you actually first get the model to break down the steps that it needs to do, this piece of work, and then to tell it, okay, you need to do this, but when you do this, you probably should go do a search, get some additional information, and come back. Okay? So the difference here is, it's kind of trying to avoid hard-coded reasoning. So you don't say do this, do this, do this, but I say do this, and then ask a question and come back. So even, it's not even about teaching it to fish instead of giving it a fish. It's teaching it to catch anything instead of giving it a fish. So you're trying to make it where it's basically it's like the same difference when we do coding about hard-coded things. Okay? Sorry. So can you put the can you put the slides again? Oh, I don't know what happened there. That one? Okay. Okay, good. Okay, so now this is useful because in addition, and the other thing as well you want to do is you want to be able to get citations. So being able to say, I got this information, or I've been giving you this answer based on this type of citations that I have. This is pretty much how Bing search, Bing Copilot works. Okay, and in addition as well, because you provide additional data, you can avoid hallucination. So here's an example. This is the question. You go to some database, okay? Then the database will give you an answer. You put that answer and the question, and then you get a language model. The language model gives you the answer. Okay? Now, a couple of problems is, if you actually end up with so much documents, well, if you have so much documents, remember there's a prompt size, is limited. So then what people do is they break down the data that's coming from the database, and they might send 4 or 5 different prompts, like queries, and then they would actually do that kind of self-consistency and see whichever one gives the same answer, the most commonly used answer, they will go for it, right? Okay, so that's that one. Okay, another thing as well that people have been doing is right now, this retriever traditionally is thought just as a kind of a dead database. It does not know anything about foundational models. But there's work right now where these two are in sync. So the foundational model and the retriever are working together. And the foundational model is giving feedback back into the retriever, into the database, so they actually can work better with it. A couple of challenges. So it is sensitive to the quality of your retriever. So the algorithm that you use to retrieve, whether it's cosine similarity or some complex embedding, okay, or if the alignment of the embedding that you have for retriever is different than the alignment you have for a query, okay, and in addition, like the one I talked about where the retriever and the foundational model are self-optimizing, that's too costly to really run that in a commercial setting. So one of the things that is kind of very new recently, which is called HIDE, which I'm going to briefly talk about, and the other thing which is called chunk drag. So the idea here again, so if you decide, I need to feed in these 10 documents in addition to my prompt, well, these 10 documents might not fit all in one prompt. So then you would take a prompt and you would create 4 prompts, 3 documents here, 3 documents here, and 4 documents here. You ask the 3 questions, you get the answers, and then if one answer is common between all the 3, you say that's the answer. Okay? So briefly, it was, oh, I thought I had a slide for, what? Oh, sorry. Just 1 minute. Is it working now? Okay, we're good. Sorry, I'm learning how to use PowerPoint today. I don't know what's happening. Okay. Okay, so we talked about this. So we talked about RAG challenges. MEMGPT is a very new work that just came out recently, and it's kind of it's similar to this idea of the foundation models or a CPU, and now the same way operating systems swap things in and out of the memory, the same thing they're trying to imitate that, where you have a limited size of a context, the same way you have limited memory, and you swap data in and out. Well, that limited space is actually your context window, and how do you swap things in and out? Traditionally, this is done on the outside. So it's not the foundational model doing the kind of the page break and actually asking for memory to be swapped in and out. Traditionally, it's done from the outside. But what they're working on is trying to get the foundational model itself to ask to to load up new context into it and do the query. Okay. Now, this is a very, very neat type of work. So the idea here is, instead of doing a search in the database based on the query, you actually get the foundation model to return a hypothetical result, the answer. Okay? And you tell it, it's okay, I'm okay if that answer is wrong, but I want an answer because that answer, the structure of it, will help me when I go search in database. I have a higher chance to get hits that will be similar to the results. So you create a hypothetical answer and you search that, whereas traditionally you would actually search based on the query itself. Today, this has been proven to actually perform much better than just a basic RAG. A basic RAG will actually query based on the question itself. Okay. React, what it does is actually, what it tries to do is to combine 2 things. So this reasoning part and the acting part. So what you want to do is you want to be able to query the environment, get some new information from the environment, and then now based on that new information, you update your reasoning and you continue on. So traditionally, either people would do reasoning or would do querying, but now React combines them both. Okay, so this is, the benefit of this, right, is you can actually start pulling data on demand. You don't have to worry about the size of the prompt. So when we were talking about RAG, you put in a big document, okay? And then you have your prompt at the bottom, okay? But with this one, you take your prompt and you first tell it, please decompose this prompt into 8 or 7 steps, okay? And then for every one of these steps, you're doing basically a baby RAG. So there's going to be much smaller data, and then you're completing that data, completing that data, completing that data. So it helps it to do reasoning, but as well it's not static reasoning because it actually is able to go and get fresh data from outside. This is an example of kind of RAG. So you want to book a flight to New York to Los Angeles, and you want so it gives an example of how to make a sandwich. So kind of what thought you do, what action you're going to do, what observation you have. So you walk in the kitchen. Now what you feel when you see the kitchen, you see all these things in the kitchen, of which one of them is the fridge. What action you're going to do, you're going to open the fridge and so on, okay? When you prompt it this way, then you actually do a prompt to find the book of flight, telling it to follow this type of learning that you taught it, it will actually start thinking similar in a kind of in a structured way. And then these observations, some of them will actually get data from outside. Okay, so you get data, for example, go query Google or Kayak to get actually the flight information and so on. Okay, so now I'm going to primarily spend the time here on talking about the prompting hacking challenges. Today, when you develop these type of FMwares, it's very costly. The best way to think about it today is anything that changes, you need to re-verify it. It's almost where, imagine we were in a world where anytime Intel releases a new CPU, it's not only you have to recompile all the software, you actually have to open up all the software and retweak it to make sure it works. So this is just pure madness. Now what's happening is this is at this moment driven by systems guys and and AI folks, okay? Whereas software engineering, the way we see it is the cost of the software is the next 25 years, right? That software is going to last forever, right? So yes, you can produce software quick, but maintaining that software is unmaintainable. Okay, so picking the most appropriate foundational model is a difficult problem. The prompts themselves are handcrafted. Any small changes the prompts gives you different results. Even the same foundational model between different versions of foundational model, between GPT 3.5 and 4, the foundational models give you different results. Okay, even GPT-4 across time gives you different results. Like the beginning of the year versus later in the year. Okay, debugging prompts is an open problem today. Today, when a prompt doesn't work, there could be multiple reasons why it doesn't work, and I'm going to talk about that later. And then there's no limit, documentation on best practices. Reimagine software engineering 40, 50 years ago, okay, where you used to have compiler dudes with, every weekend we think, oh, I have this cool way to optimize how I can lay out the data on the chip and the cache. And then another guy would say, I have a cool way to do this. And that's exactly where we are, okay? This is not sustainable. This is not how grown-ups build software. Okay, then as I said, so the prompts are very costly, especially as they evolve, and then the efficiency is another problem. If you look at Microsoft, Microsoft is actually losing a lot of money on Copilot and all these things, right? So it's very hard to actually do this in a financially viable way where you're optimizing for the performance and the scalability. Okay, so there is a lot of work on kind of starting to create best practices. Think of them as design patterns for prompts. I'm kind of gonna skip on these. This is a lot of kind of different ways. Current prompt engineering practice. So here's an example. If you consider this prompt, where's the capital of Japan? Every one of these foundational models is going to give you different results. They're not portable across foundational models. This is the same question asked in March 2023, asked in June 2023. It's giving you different results. The same foundational model, didn't even change it. Okay. Actually, I don't know if you saw recently, we're saying that GPT-4 is getting much dumber. Okay. And it's because the problem is right now is, remember the thumbs up and the thumbs down when you give it. So actually, if enough people give thumbs down to the right answer, the question, it will become to the wrong answer. So if 2 + 2 = 7, and enough people on this planet give it thumbs down, it will become 7. Okay, so there's a lot of problems around this. Okay, the other thing is, the complexity of prompting continues to increase. What we're envisioning today is we cannot continue doing this. We really believe there will be the kind of prompt compilers will happen, and instead of prompt hacking, is going to be intent programming. So you're going to tell it what you want. We're going to have so many different patterns of prompting, and so many different patterns of bringing data in. And all of that will be combined together. Now, does this sound like crazy magic? No, it's not, because this is exactly what happens 30, 40 years ago when compilers started. Every person was tweaking the bits and laying out the data differently. So this will happen moving forward. Recent work, a month ago, Google released what's called Prompt Breeder. So what it does, it actually uses genetic algorithm to find an optimized prompt. Okay, Stanford as well has a new programming model and a compiler for prompting. UC Irvine and UC Berkeley as well have this automatic prompt engineer. So all of them are the same idea, is end users should not be spending hours and hours tweaking prompts. This is not how grown-ups develop software. As well, there's new work to do, again, like this scripted prompting language. It's very reminiscent to kind of server-side ASP. Okay, so this idea you put patterns and it gets replaced at runtime. Okay, then you can do a lot of kind of reuse of the code, because that's one of the biggest problems. You want to be able to do code reuse. Again, classical software engineering. So what we're seeing is the revisiting of many things around software engineering. Now the good news about this, and this is why software engineering will never go out of business, is there's so many problems, so many bad code in the world, and it's always, whether software engineering helps at the beginning or helps at the end, there's always business for a software engineer. Okay, there's so many bad developers. Okay, so, the systematic testing of prompting results is a problem too. How do you actually compare the different outputs of the test cases? So remember, one of the big things we do in software engineering is test-driven development. That was a big thing we pushed, maybe 15 years ago. So the idea is you need to have a test suite that's repeatable, such that if you do any changes, if there's a bug, you can find it. But now when the foundational models are non-deterministic, when the results cannot be compared, that result and that result. So I could solve the same code completion with two very different pieces of code. So I cannot say, oh, this time you generated this code, but this code is not similar to the code I have in my Oracle, therefore you failed. No, because both of them might have actually been solved the same problem. Okay, there's a lot of benchmarks to kind of evaluate them, but the one I want to spend a bit of time to is that debugging of the prompt and building high quality AIware. So the question right now is, you issue a request to a foundational model, you prompt it, and it doesn't give you the right results. There's a couple of things that could have gone wrong. First, it could be that the foundational model didn't understand your question, right? Or it could be it understood your question, or it failed to actually answer it. Okay? So in that case, if it understood your query correctly, but it failed to answer, that means you need to improve the foundational model itself. In that case, you either go for a larger foundational model or you fine-tune your foundational model. In the other case, the foundation, didn't even understand your query, right? So now in that case, you need to look into prompt engineering, improving your prompt, if the prompt has any kind of anti-patterns in it, because the foundation model is misreading your prompt. Okay. Now it could be that it understood you correctly, but it didn't. But you didn't give it enough context to answer it correctly. So when I talked about the foundational model patterns, the prompting patterns, all the way till we talked about RAG and React, these were you were not bringing data from the outside. Once you bring data from the outside, it could be the reason you're not able to answer the question is because the data you're bringing from the outside, from the RAG or the React, is not good enough data. Or either it's dirty data or it's not the correct data. Okay? Unfortunately, today as AIware developers, all of this is done in an ad hoc manner with very limited tool support. Okay? So, these are some ideas of kind of where we see, foundational model and software engineering being applied, right? There is work today on something called RAGAS, okay? And what it does, it creates two different scores when you're doing debugging. What's called a generation score and what's called a retrieval score. Because remember, when we're doing a RAG, we're actually retrieving some data and we're generating something. So when something breaks, it could either because the generation itself broke or because the retrieval itself broke. Today, as a software developer working in this thing, a lot of this you kind of have to hack them together. There's no support for them. So we believe that a lot of this, and that's why we believe the whole software engineering needs to be revisited for these type of applications. So this calls, when we come with generational score, so how faithful you were, how relevant the answer is. Now when it comes to a retrieval score, so it's a classical retrieval, precision and recall. Did you give me so much data that I put on the top of the prompt that 80% of it was useless? Did you even give me the relevant data that I should have put on the top of the question before I sent it in to the prompt, to the foundational model? Okay. So kind of wrap up on foundational model where? So key point is I kind of want you to get from here, bigger is not better. Prompt work today requires a great amount of trial error. Now, there are attempts today to create pattern best practice, but with limited support for automation and verification, right? We believe today that prompt compilers are a promising direction, and there's a really big need for rigorous, and verification, especially continuous verification. So test-driven development kind of things. Okay, so I didn't cover a couple of things today because I want to move on to the foundational models for software engineering. Okay, fine-tuning and alignment programming is a big problem that needs to be solved. When you decide you fine-tune versus you prompt. So traditionally, people say, oh, you prompt, and then if you can't get any better, you need to fine-tune. But actually, it's a back and forth. It's not a straight line. Okay? And then the whole idea of how you do orchestration and agents. So these are other topics that usually I cover, but I'm not going to cover them today. Okay? The best way I can get to you is doing a demo is cool, shipping a product is hard. Shipping and scaling a trustworthy product with non-deterministic and rapidly developing core, which is the foundational model, while making money is beep hard, okay? So that's kind of the big message here, right? And this is really what SE is all about, making something unreliable and unstable a commercial and responsible and viable reality. So, if people in software engineering, I think there's a lot of things that could be done in this area. Some key challenges, right? Software design and requirement engineering with human in the loop is a big thing. Early on, we were talking about this type of software, this conversational type of software. How do you even do requirement analysis for this? And I really believe, requirement has had a very hard time in software engineering, right? It's very hard to do requirement engineering. This might be the chance where requirement really can rise to the occasion, right? Semantic telemetry is another important challenge. How do you know if the user is happy and appreciating of the application? So with GitHub, it was not with GitHub, it was Copilot, not Copilot, ChatGPT gives you the thumbs up, the thumbs down, okay? With Tesla, it actually detects how rough you turn your steering wheel. So this type of context, not just basic telemetry, which is raw metrics, actually telemetry that's capturing the experience of the user, okay? Test-driven development and evolution is an important thing. So this eval-driven development, what are appropriate evals so we can evolve it safely and reliably? And then how do you evaluate the prompts, the retrievals, the foundational models, and all of them combined? Because when something goes wrong, there's so many things that go wrong. And the biggest challenge today is software developers, they change 6 things and then it doesn't work and they can't even remember which 6 things they changed, okay? So that's why we really believe that there's a need to a full platform, like a full life cycle platform that really kind of makes this an engineering discipline. We cannot continue the way things are today. Software performance engineering is another big thing too. So the idea here is traditionally when we try to make something faster or slower, it's only about cost and speed, but it's not about we can give you bad results. But in this case, you're actually playing where maybe, I can make it cheaper, and yes, there will be 5% of the times I will give you wrong results. Very different way of thinking when we do performance engineering. Semantic caching is another thing. Okay, there's a typo there, semantic. So the idea here is you want to avoid going to the foundational model. So traditionally when we had web systems, we put caches in the front, but the caches were like, okay, I'm looking for this exact question, I'm only caching this. But now you want to be able to cache this question and semantically similar questions to it. So I think there's a lot of work that needs to be done there. Okay, and then this whole kind of balance between the prompt, the fine-tune, the retrieval, the model, all of them co-optimize, because I really do believe the foundation models, if you only focus on the foundation models and you don't realize it's all of these things working together, you're not going to reach the optimal software, right? Now, other things kind of moving forward is beyond geek software engineering. So the software maker software engineering, how you enable end users, domain experts, and SE experts, all of them to collaborate together, in an inner source and open source world. Because the barrier now of contribution is much, much lower for a non-expert, okay? And then governance, I think there was a question on like, somebody created GPT and the GPT is telling everybody about their credit card information and all that kind of information, right? So how you can make sure the data is governed and managed in the right way. Okay, so this is kind of the end of SE for AIware, and now I'm going to move on to Intelligent Software Engineering 2.0, so FM Augmented Software Engineering. So if there's any questions, otherwise I'll... Okay, we'll continue. Okay, so this idea here is how to use this AI where to support software engineering activities, kind of focusing on achievements, opportunities, and challenges. I'm not going to spend as much time on really highlighting, what you can do. This is more of a critical thing, trying to point out what's wrong, what challenges are there, because there's a lot of interesting surveys that are happening today. A brief history, so in 20 plus years ago, I myself, had created this community called the MSR community. And the whole idea was there's so much data that exists today, how we can actually take all this data and help software engineers with their next decision. Okay? And the idea was to use AI for a lot of this. Okay? But now what we're really seeing here was this intelligent software engineering 2.0 is the emergence of an AI teammates. So these teammates working with the developers, and the key point here is that they are collaborating together. They are not there to replace the developers. They're trying to get the developers to do less of the boring stuff and to focus more on the exciting stuff. Okay. Now, Sequoia had an analysis a year ago on this as well, and what they were saying is, okay, where is development tools 2.0? So the idea here is how we can leverage these foundational models to help to create the development tools that will support developers, right? So, and this is, many other roles than just the software developer, because there's so many people in a software engineering project, not just the coders. And actually, we know from studies that the amount of time that developers spend in coding is very small compared to what they do in a day-to-day life, okay? So, but right now everybody's fixated on this, the code part. Like most developers don't spend 90% of their time on the IDE, okay, unless they're very low-level developers, okay? So, that's kind of what Sequoia is kind of pushing for. Now, this being said, so there's two great surveys. So there's large language model for software engineering, a systematic literature survey, and there's large language survey and open problems. Hello. Okay, so what we know today is there are many, many attempts to use foundational models to help with software engineering kind of problems. 65% of them, are using them for generative purpose. Otherwise, mostly they're using them as just bigger neural networks. Okay, so remember I said there's software 3, it's a software 2.0, it's more of a neural network, and in software 4, you can either use them as just a bigger neural network, or you can use them actually for their generative capabilities, their reasoning capabilities. Okay. A lot of it is kind of done, as you can see here. So there's 62 studies on, on code generation. Okay, a lot of the studies really around software development, very little on, engineering, on design, management. There's very little as well on there. Okay, as well when you look at the data that's being used, most of the data is actually code-based data sets. So 70 plus studies are on that. Okay. Now, there's a lot of foundational models that have been fine-tuned for code, okay? So that's some of the examples of them. Code Llama is kind of the most recent one, out in August of this year by Meta, okay? Now, the way it works, so the foundational model assisted coding, so what you're doing here is you type in swap equal, and then the foundational model actually would generate all of this, okay? Now, there's a couple of ways this could be done. So now you need to figure out the prompting part, right? So you need to give it context. You can give it just the code above. You can give it just the code. You can give it the code above and the code below. But not in addition to that as well, what really, when Copilot did their study, they found it wasn't just the code above and the code below. What mattered too is the other code that was open in the IDE at that moment. So that helped too, okay? So the key point here is it's not just about giving it a prompt, getting an answer. The context, what the developer is working on at that moment, matters quite a bit. Okay, so as I said, so there's many, many great studies on this. It's going to improve productivity, yet there's many unanswered questions as we move this to the masses, okay? And one of the key points here is, my view is academics are really focused on benchmarking one-shot code generation. So I give you a question, you give me the code. And if that code is right, you're good. But when you look at Copilot, that's not how they work. Their point is, I give you a question, you give me an answer, I tell you it's not good. We go back and forth, and it's really this idea of conversational coding assistance. Very different than just right, wrong, right, wrong. One is really trying to figure out how we can replace developers. The other one is how I can augment developers. So you can have a model that actually never produces good code that's ready to compile, but it always produces code that is easy for developer to do a little bit of edits to finish their job. Okay. That kind of perspective is not studied at all, right? So productivity versus correctness is a big challenge, right? As I said, so human-in-the-loop software is a big type of software today that we have never thought of how to design. And I think this is really one of the big strengths that Copilot has really kind of get in. And even when you saw the demo today, what he did is he could have done everything. So he could have generated the plan and done everything magically. But he actually showed the developer the plan. And the developer then said, oh, remove this, add this, and then go execute it. This way of thinking goes against most way of thinking for us as computer scientists, because the idea is computer science is we're going to automate everything. So I believe there's a big way of difference in thinking, okay? That back and forth interaction is very important. Okay. Now, how this is evaluated today? So there are really 3 ways to evaluate this. So human eval, so what it does is people sat down and they created functions. For example, write a function to sort a linked list, and somebody wrote it down and they wrote tests for it, okay? This is the one that's kind of used the most. And then last year, middle of last year, Huawei and PQ created a new type of eval. Just a second. So the problem was the first eval, it was like kind of programming exams. Nobody writes programming exams on a day-to-day basis. You know, like all these elite code kind of stuff, right? You write today you're writing code that you're bringing a lot of libraries together and you're doing all the scaffolding and all that kind of stuff, right? So what the folks at Huawei and PQ said, yeah. So what we should do is we're gonna get functions from open source. So these are real functions. Okay, but then when we have these real functions, they don't have tests. So then they went in and they wrote the tests for them. Okay, so now and the reason why they write the test is because 2 foundational models generate a result. You can't just simply say, okay, these, you can't do text matching, right? Because both of them might look very different code, but both of them are solving the problem correctly. So the way we do the verification is by actually running the same set of tests on here and the same tests on here, okay? Eval Plus, what they did is they took these benchmarks, whether it's human eval or code eval, and then they actually using actually mutation-based strategies to create new tests and to remove tests. So they could say, you can add the foundational. So first, the mutation testing, what does it? Takes a piece of code and kind of modifies it. Okay, so then from one test, you can create like 5 tests. Okay, but then you end up creating a lot of like redundant tests. So then they go to the large language model and tell, these 2 tests, do you think they're testing the same thing? And the foundation model say, yeah, they're testing. So then you can remove it, okay? So this is a kind of, I like this work. Actually, this is Liming, he's actually attending here, he's in the vision. What's nice about this is the realization that it's not when foundation models appear, we're gonna forget about everything. So he uses foundational models to help him verify whether tests are similar. He uses classical software engineering to help him create other tests and combining them together. And this is very rare because people are like, either I'm all the way in foundational models or I'm a classic dude. This kind of bringing back to the 2 worlds is very important. Okay, yeah, so again, the other thing is the shallow analysis of the results. So today we know that Copilot, they say around 30-something%, people willing to accept the recommendation, right? We know very little about, how about the type of software? Maybe for system software, 90% of the time is not accepted. We know for sure that for AI type of software, data analytics type of software is probably 99% accepted, right? But all of that has been combined into one number, right? It might help junior users more than senior users. A couple of things that we know that have just appeared recently is first is that junior developers have a higher chance to accept these, but that doesn't mean that, you have to be careful because first it could be that junior developers get easier tasks It could be as well that junior developers are clueless and they just happen, they'll click on anything, okay? So there's this correlation and causation thing, okay? There's very few studies on C and low-level type of software. There's only one, like basically two numbers that we've seen in literature, one by Meta and one by Google, where they showed a little bit lower performance than, say, you know, trying to do code completion in, what is that thing called? Like data analytics, kind of Python type of code. Okay, now I'm going to talk a little bit about this Meta study because I really like this study. Not because Nash is one of the co-organizers, but I like it because they actually put it in production and they talked about the lessons that they learned, okay? So here's the study. So this is the C, okay? So here in that case, they had 21% acceptance, right? And then, for example, Hack, they had 22, Rust, 17%, and so on, okay? These numbers are actually much lower than the numbers that Copilot reports, okay? Now, one of the things is, you know, really recognizing, one of the things that they did, I believe, very importantly and very well is they consider the characteristic of source code. Source code is not simple code, okay? So they basically made sure they don't train on code with obsolete patterns, okay, or you know, code that's not in production. They only train on code that is actively modified. So they said, yeah, it is true. Yeah, we have code for the last 20 years of Meta, but we're only gonna train on code that today an average developer would actually be using. Okay, so that made sure that the recommendations are more kind of aligned with what people are doing today, right? And as well, they use special tokenizers of code. So for example, import NumPy as NP, that whole thing is a token. That makes the model much more optimal and has much less tokens when it's running, right? Whereas if you only think of it as text, so import is a token, NumPy is a token, as is a token, NP is a token, right? Okay. The other thing is they really focus on the conversational aspect of the tool. Okay. So one of the things they realize is developers are fine with reworking a suggestion as long as the model provides that starting point. And Ed today as well was kind of mentioning the same thing from Meta, right? Saying, I want to get the get me going, get the boilerplate, and then I'm going to work in there, right? The other thing too, which is very interesting, is while their model is able to generate the whole function, they do not generate the whole function. They only generate one line at a time, and they still kept so they have the capability to generate the whole function. And they kept that capability. You could click a special key and it will generate the whole function. But developers never use that. And the reason is you're either coding or you're reviewing. But when the code generator just briefs you all the code, you now totally move your mental model from just coding to now you have this big blob of code you're reviewing. And then as well, they looked at the latency. So for example, they said 300 to 500 millisecond, is an acceptable latency. So what they did is they use caching, they use the delayed, batching, okay? As well, made sure as well that they're not querying the model so frequently. So it's not every time the cursor moves, they actually do another query. Okay, and then they went in, they had a 6.7 billion model they started with, but now when they put it in production, was a 1.3 billion model. These numbers are very small, right? But this works and this is what they have, right? So this is something you want to keep in mind. Now beyond this segment-based coding, so today most developers don't just code little functions here and there, right? Actually, to give you an idea, Copilot is not able to remove a line of code. It can only add, okay? And Copilot as well will not tell you to do this change, you need to change in 3 places in this function. It only works on this thing. So what we call just segment-based coding. This is not what people do. You actually start from a feature request, which probably could be broken down to 5 or 6 GitHub requests, issues, and then you start from there, right? So there are 2 works that kind of have come. So in September of this year, Microsoft India had CodePlan. What CodePlan does, it pretty much combines classical program analysis. And the reason it's doing classical program analysis is because it needs to have a bigger understanding, a bigger context of software. And not looks at software as just text, but it needs to understand the call graph and the characteristics of the call graph. Okay? And then they pretty much have a foundational model and they do all of that kind of things in there. Okay? And then, A week ago, Copilot was released, the Copilot workspace. The biggest kind of innovation here is this one here is still thinking of the classical way where the developer is not in the loop. You give the request, it goes in, it does the plans, it queries the plans, it does all this. Whereas in the Copilot case, it's more of an agent-based system where it comes and asks you for clarification. It tells you, this is what I'm going to do. Are you okay with this? And then it executes that. So yeah. So that's some of the kind of the new innovations. And I think this is pretty much where we want to be going more. It's not at the segment level. Instead, it's knowing to do this big change, I need to change these six files, and then in this file, I need to change in 3 functions, and then in this function, I need to change in these 3 places, and then at the bottom is Copilot. Okay, so there's a lot to be solved. So, this is not the end of programming, right? There's a lot of problems that still need to be done, right? Another thing is this multi-agents for software engineering. So chat dev is another thing. So the idea here is, can we use all these kind of ideas from multi-agent programming to automate the whole software engineering cycle? The problem right now, so we have used these. So one of the big problem with them is they consider what we call green development. So they just say, okay, every time you have me a request, I'm going to regenerate your whole software system. And not only that, if you just hit recompile again, I'm going to generate a new software system. That would just drive everybody crazy, okay? So these are interesting attempts. I think they're very cute. They have a lot of nice demos and things, but this is very far from ready for development of software systems, okay? The other thing as well is these agents, they have limited knowledge of software engineering. So they don't understand, for example, that most software engineers prefer not to change code, design patterns, architecture styles, all of these, the agents need to be actually taught about these kind of problems. Okay? And the other thing is the agents themselves are not getting better with time, which we think is a very important thing, because the same way when you hire a new developer in the company, the first year you probably give them easy code to fix, and as they get better, you give them harder things, right? But today, whether it's agents, whether it's Copilot, remember I said, like, if you give Copilot, ask him a question and gives you the wrong answer, and you're telling the answer is wrong, Copilot does not have the ability right now to improve on itself. Okay? So what we really believe in moving forward is there's going to be this idea of agent gyms. The same way when basketball players, they buy a nice home with a big basketball court and they keep on throwing hoops over and over and over. These agents will actually have their own gyms where they will train to become better. Okay. MetaGPT is another answer. Again, the biggest problem again is targeted greenfield development, very unrealistic philosophy. No native support for repeatable results. It does have the notion of some of the software their agents have knowledge of software engineering, but the interaction that they have is pretty much actually a waterfall interaction. And we know that today a tester might want to go all the way talk to the requirement guy. Okay, so that kind of flexible interaction between agents is not there. And again, the agents learning over time and evolving is something that they're missing. Okay, so now this is pretty much, so every one of these is a couple of PhD theses. Okay, so okay, so a couple of things here. The examples of the limitations. So they have very high risk for junior developers. What we know today is that senior developers are easily able to figure out if the foundational model is wrong, and to actually not accept it. Junior developers don't have the experience, and they might accept it. Okay. In addition to that, there's a very important need for guardrails. So there was a study that was done where people were given answers that came out from. So they asked Stack Overflow. So there were questions that you find on Stack Overflow. And the answers were given to the users. And the users actually preferred the ChatGPT responses over the Stack Overflow responses, even though the Stack Overflow responses were actually incorrect. Just the way it's written. So, they're basically deceived by how nicely polished it is versus actually realizing the kind of the essence of it, okay? Copilot as well, there were studies that showing that, similar vulnerabilities as developers, around 33% of the time, okay? But then, as well, it actually likely to propose some types of vulnerabilities over others. So there's a lot of work that we need to be done here and try to fine-tune this to at least avoid them. Because the idea here is you want to replace them, you want to replace developers that create vulnerabilities, But ideally, you don't want them just, what ends up happening is they're just creating different types of vulnerabilities for which we don't have the tooling to support that type of vulnerabilities, okay? So at least right now we've been building on the vulnerabilities that most humans are creating, and we have the infrastructure for that. So if we start getting a new type of code writer and they're not generating the similar type of vulnerabilities, we actually need to recreate the whole kind of pipeline to catch these type of vulnerabilities. Licensing issues is a big problem too, okay? There's a lot of limited attention to licensing. So today, for example, GitHub says that 1% of its 1% of its suggestions can suffer from code provenance problems. But the way they do it is they look at 150 contiguous code tokens. And if this 150 code tokens that they suggested don't exist in open source, they say, we're good. But the reality today, when it gives you a suggestion, one of the things it will do, it will actually replace the variable names in open source with the variable names of your software system. Which means for sure in 150 tokens, you will end up replacing a couple of these tokens to basically use the same variable names. Okay. The other thing too is, so Copilot had kind of been pushing on this, saying for the longest time it's not a problem. However, in June of this year, they actually provided a tool for post-analysis, which means a lot of companies are saying, no, I don't believe this. So they provided a tool for that. Amazon has always provided one. Now, the recent thing that a lot of people are doing is this legal protection. So Microsoft has a legal protection that says, if you use Copilot and you end up being sued for open source infringement, don't worry, we'll come and protect you and we'll stand for you. But if you read actually carefully in the requirements, it will actually say, but if you change the code anywhere by even 1 bit, tough luck, including enter, including a semicolon, including actually even re-indenting the code, okay? It's not a realistic one. The last lecture in the school, actually, Daniel German is going to talk a lot about this. Okay. The other thing is there are studies that show that copilots tend to steer developers to develop a lower performing code. Okay, and then the other thing is, it's very complex to debug and understand the challenges. So it's hard to understand and debug the large kind of code that's being generated. So if you're working on Copilot, it just throws all this big code on you. Now, it's very hard for you because it's the same way where if you go to a TA to ask you to help you, answer this question, instead of them giving you some hints, they give you the answer from last year and they say, it's just the same, but you just need to modify a couple of places. But now you're going to spend all this time trying to understand the answer, so that becomes much harder, okay? And then, as I said, this whole, developer AI, cooperative kind of interaction, conversational cycle is missing, okay? Other things as well that we know today is that it has very limited design capabilities. A lot of times, so there were studies where they did is they gave developers Copilot, and they gave other developers, didn't give them Copilot. And then they asked them to solve the same problem. And they found in some cases that the developers that were given Copilot took longer to do the problem. And a lot of times they didn't finish it. And the reason is you as a developer, you look at the answer coming from Copilot, and then you say, oh, I think I could change that to fit my need. But that decision, I think I could change that to fit my need, is a very risky decision, okay? Because now it kind of throw you in exactly a very specific solution, right? So, for example, it could be something that can be solved, by just running for a list, and instead Copilot generates for you this code that's going through multiple linked lists. Okay, and you say, oh, I can modify it simply. So now it already pushed you down the wrong path. And the biggest challenge today, especially when it comes to junior developers, they don't have a bigger perspective of, no, this does not look like where I want to be going. Okay. Today as well, there's a lot of brittleness in the interaction. So today, the Copilot, what people do is sometimes when you're using Copilot, if it's not giving you a suggestion, you start writing comments, okay? And then the idea is that these comments are you trying to prompt Copilot. The biggest problem is any change to these comments, maybe even adding an S for plural, can actually generate different code, okay? And in a way, it has changed how people develop code. So traditionally, we write code, and then you go comment it, okay? But what's happening here is there's a new type of comments, which are prompting comments. And then once you're done with these prompting comments, you remove them. Which is actually, in a way, you have to think about it. Imagine now if we kept these prompting comments, because later on, in 5, 10 years, we might have better foundational models that could generate even better code than what you have. So whether these prompting comments need to be maintained and kept in the code is a very interesting problem that needs to be considered, right? The other thing which a lot of people are kind of excited about is ChatGPT, or Copilot being able to generate tests. So here's the reality, okay, is tests, the way we do them in software engineering, is based on requirements. It's not based on code. Okay, I hate to break the news. Yes, it will generate a lot of code, and you're going to get good coverage. Whether that will actually satisfy the requirement, no, because the requirements were not part of this. Okay, so this is a trick. So yes, on the measures of code coverage, yes, it will cover the code. On the measure of functionality coverage, customer satisfaction, it will not do that, at least today. And this is why we believe that requirement engineering needs to kind of pick up here, and we try to figure out how to get this working. Okay? And then, a lot of the work today, as I was saying, is they're looking at this point-based solution instead of end-to-end solutions. So a lot of times, as I said, foundational models are very good for reasoning, but as well, they're very good for just generating things, right? Parroting. We're seeing more and more of this parroting capability and very limited uses of the reasoning capability. So putting plans and then executing the plans. It can do both. But if you're only focusing only on the executing, you're not really getting all the benefit of these foundational models. Now, a couple of things, kind of opportunities, right? This idea of software engineering aware foundational models. Current code really continues to treat code as just text. But the reality, code is much more than text. We have a history of it. We know what's good code, we know what's bad code. We know who wrote that piece of code, we know how long they wrote that piece of code, we know what that piece of code ended up causing problems in the field or not. Where an essay, we don't know anything about this. And today, very little people are looking at that. There is actually in the next session in the school, so there's folks from Google that are going to be talking about this Google Didact system, which is actually one of the first systems that look at the foundational models, and try to make sure we're treating them and training them with software engineering knowledge, not just treating them with just bare text. Okay? Combining foundational model and classical software engineering techniques. So it's not either you do foundational models or classical software engineering, so code analysis, dynamic analysis, static analysis, all that kind of stuff. Combine them together, and I gave 2 examples of that. So that eval class, which actually would take and created more tests and then filtered the tests using GPTs, and then Microsoft Coplan. Okay. Other things that are interesting is hallucination today is considered to be a bad thing. Okay. But in reality, you know what hallucination is saying? It's saying a person who's smart enough would think that that feature should exist. So I'm going to assume that feature exists, right? So it's actually really telling you if somebody's smart enough, he's actually giving you a suggestion, okay? How you can use that now to start planning the capability of your software system. Because the reason the GPT was generating that type of hallucinated code because it felt that actually would be the right way. You really should have this feature. And that's what happens even when you train young students. They would call functions that don't exist, and then they'd be surprised, like, why you don't have that function? And sometimes you really, as a professor, you're like, yeah, I don't know why, but they don't have it, dude. It's not going to compile, okay? But this ability is something that could really be harnessed to evolve software and actually make it better fit the uses of that type of libraries, for example, right? I think I mentioned this earlier, the foundational models as data taggers. As we're seeing more and more that happening in the business environment. So a lot of companies today use GPT-4 to do a lot of data tagging for them over having, outsourcing that to individuals. This could be as well leveraged quite a bit in software engineering. And then testing, right? The non-deterministic nature, the hallucination, the multi-agents, bring a lot of their own challenges when it comes to foundational models. Okay? The other thing too is the rigor of the evaluation. So, I mentioned there's 229 papers, right? So one person went through and they said, okay, let's look at the ones that are doing testing papers. So they use large language models for testing. And now I have a criteria to meet whether I can replicate this study. And he ended up removing 90% of these studies because either the parameters were not defined, the data is inaccessible, and all these things. Okay. The other thing too, so Tim Menzies is a colleague that specializes in, in machine learning, classical machine learning, and he said, from all these papers recently, only 5% of them comparing them to simpler non-neural network models, and as well the comparisons when they're done on non-optimized parameters. Okay. I think, yeah, we talked about this point-based solutions instead of end-to-end. Trustworthiness of FMware, so that was the question about like GPT is now telling you everybody your credit card and all that kind of stuff. So, how do you deal with data leakage, copyright, scalability, performance have very limited coverage today. Feeding the software engineering and system context into the foundational model is very important. So how today, how do you feed your whole software system into Copilot so it can help you do the code generation, right? Today we feed it a couple lines before, a couple lines after, right? But then the reality is, it does have no idea. Maybe you are using a specific design pattern in this function. Well, its view is very limited of the world, right? Okay. The other thing too, what we have recently discovered, which is interesting. So the idea was that if you have a lot of data, and you're trying to deal with the prompt limitations, is you should do fine tuning. Okay. So the idea with fine tuning is you're shoving all the data into the model. But what actually recently been discovered is when you shove all that data into the model, the importance or the priority of that data becomes the same level of importance as the rest of the world's data. So when data is coming at the prompt, the model in a way implicitly is known that that data is more important, I should listen to it more. But when now it becomes part of the model, it's no different than the data coming from Mozilla, coming from any open source project. So that's one of the challenges. This fine-tuning is not always the answer, okay? And then, as I said, so there's a lot of missing areas. Surprisingly, there's very little work on refactoring. Okay, Ali's a big guy in refactoring, right? So there's almost very little work on refactoring. Surprisingly, there's very little work on requirement. They're not explored at all. And really, I think there might be the golden age for requirement engineering. The best way I can kind of describe it is this is how software engineering has evolved. We went from the idea of manual software engineering, okay? Everything manual, human doing all the work and coordination. Then we went to automated software engineering. So you have automation with human coordinating the tools. Okay. Then we went to intelligent software engineering 1.0. So this was software 1. So this is basically codeware and neuralware. Automation still was human actually doing the coordination. Okay. Now there's more circles here because with neural type of software we can solve more complex problems. Okay. Now where we are is kind of here. So intelligent software is still, I believe it's still, I want to call them, we're still at 1.0, still not really, we haven't reached 2.1, okay? The idea here is you're taking software 1, so that's codeware, neuralware, promptware, but it's still, the human is the one coordinating everything, right? So, I want to put a feature, that feature requires changes in 20 places. I do prompt copilot here, prompt copilot here, prompt copilot here. I'm responsible to keep that everything in my mind and coordinate it and make sure that the change here is not conflicting with the change here, right? This is not where we want to be, right? What we really want to be doing that is software 2.0 with agentware, right? So these agents that are backed with 1, 2, 3 software automation technology, and even doing considerably less coordination instead the agents are co-interacting and evolving. Now, is this science fiction? I don't think it's science fiction, okay? And the reason is we've already seen this where, what is their name? Tesla has done this, right? So Tesla first, what they started with is they say, okay, I have all these cameras, tell me the lights, tell me the pedestrian, tell me, the other cars. And then after that, they take all of that, all these signals, and then they were writing codeware, so software 1, to coordinate everything with tons of if statements. And their big aha moment was like, this is a really hard problem. And really, to be honest, nobody cares there's a pedestrian, nobody cares about there's a light. What we care is, should we stop? Should we turn left? Should we turn right? Should we go straight? So why can't we actually build models? And my belief, I would say 4D models. So basically, it's a time model and a 3D view of the world. And the model answer for me wouldn't tell me there's a light or there's a pedestrian. It would tell me, if I were you as a human, I would take that left turn. Okay? The same ideas that Tesla has done, I believe, could be done in software engineering. Okay? And the technology already is, we're almost there on that. Okay? And why we believe that this is happening and why this is important. This is feasible today. If you think today this is the complexity, so the most complex program in the world is kind of around here, okay? And then our little human brain has this capability. We can only write code in this little world here, because this is how far our brain can fit with if statement and loops and so on. What happens now with NeuroWare is we actually increase the complexity of the software we can write, because we no longer actually need to write the code. What we do is we define a search space, and that search space is defined based on data. Okay? And then we tell the neural network, go find me that code, go find me that solution, and then it will come back to your solution. So now the program you're writing are much more complex than we could write before. So this is, you remember when I talked about the wiper system, right? The wiper for cars, right? The windshield wipers for rain. Okay? Writing that code is very hard. But if I give a lot of pictures, the neural network will find that code. Will find the software system that will solve that for me. Okay? The problem now with this is there was a lot of data tagging that's needed. I needed to tag a lot of pictures of this, a lot of pictures of that. What happened now when we went to foundational models is we are able today to use the same tag data to do multiple tasks. Okay? So we need to do less tagging, we could do a lot more data reuse, and the foundation models themselves are much more capable. They're no longer tagging, but they could generate things. Okay? So this went from this flat view to actually cylindric view. So that's why we believe that was actually the capabilities that they have enable us to actually solve much more complex software system problems than we're able to do today with code, where we already know that this cannot solve a lot of the problems, and we know that this is already very promising. Okay? So, conclusions. Okay. And then we'll take some questions. I hope, with the panel we have today, what we talked about is, software is changing, and we really need to reimagine software engineering. And at the speed of how AI is going, we need to reimagine at a much faster rate, right? Many things are happening here, right? This idea of conversational software is a new type of software. This idea of software makers, end users actually being part of the SE end-to-end life cycle. Okay? A lot of people think that this is, this is the end of software engineering. Actually, as I said, this is the calculator moment. This is where people actually everybody will be doing programming. Okay? Now, what happens to the traditional software engineers? Well, guess what? There's a lot of plumbing at the bottom to make this happen. This is not like magic at the bottom, right? Okay? The idea as well, we mentioned earlier, this idea of software that is perfect versus software that is good enough as an average human. So all of these really need to rethink what exactly is the definition of software moving forward. Now, is this going to solve every software? No, like every problem in the world? No. But I believe slowly it's going to solve more and more problems, right? Now, SE for AI aware, right? So, it's AI becoming very important. So this is how to actually get the whole end-to-end software engineering life cycle done right for developing this type of software. Okay? And the reason is this really needs to be done now, because otherwise the future of software engineering would be written by AI and system experts. Now, the good news, this has happened before. So a lot of the web innovations and a lot of the web code, has been really, software engineering has not been involved in it as much. But the great news is there's so much legacy code that's crap, And there's going to be so much maintenance people in software engineering looking at it, right? So, you know, whether we jump now or later, still there's going to be a lot of interesting things to do from a software engineering maintenance point of view. But the reality is, for this type of software, trustworthiness is actually at the core of it. It cannot just be added at the end. Okay, so this really needs to be done now instead of a band-aid solution. And then I kind of talked about AI-aware for software engineering, so that's intelligent software engineering 2.0. You know, however, many of the current effort are still building on software 2.0 based software systems. So just a foundational model is just a bigger model. But the reality is we need to get the human out of the loop a bit, right? Really, humans should not be coordinating the work of GPTs, of Copilot, right? Because it's crazy, because Copilot does not know the links between these two functions today. So that really needs to be kind of linked better and push that down into the AI to manage that for you. But while in the same time, as we have seen was, you know, the recent work that just came out from GitHub, is you still need to have the human in the loop, ask them for approval on the plan before you start executing. Okay? So that's everything I wanted to cover, so I want to leave the few minutes for kind of discussions and questions. Okay, yeah, just a second, they're going to get the...
So much. Hassan, I had a discussion, I think 4 days ago or 5 days ago with Joshua Benjo. So I asked him this because he has been emphasizing and talking a lot on regulation. So he's, from what he expressed was, it's dangerous to send these kind of models to open source even when the regulation is not everyone should lay his or her hands on this kind of models. I understand he's not from software engineering background, and I don't know if, from what you have said, I think it's a reality for us to invest in this kind of technology and, you know, try to bring our skills also to help it. So my question now is, if this coordination from the software engineering and the AI system, if the two big parties are not really like coordinating,
yeah,
how will people fit in the loop? Because we need to come in, and if, let's say, the AI people don't believe in certain core values, then that collaboration, how do you see that coordination or collaboration happening?
Well, I think you need to be careful. So there is what you're seeing in the news about what everything GPT can do and what really grown-up companies are doing, right? So a lot of companies are not just jumping in, right? A lot of companies do realize that the big challenge with software is not actually writing the first version, is being stuck with it for the next 20 years. Okay, so that's one, right? And the second part of your question was on the risk of having that in the open source and stuff like that, right? So there's a couple of things. So first, there was a recent model of a Mistral by a French company, right? Where they actually released a model that has zero protection. You can ask it anything, man. And it will answer whatever you want, how to kill somebody, how to hide the body, is available online, okay? So it's already happening, okay? The reality is the following, and I think Sal Khan from Khan Academy, right? And I had him at the beginning because I really like his code. He said, like, okay, there will be good people and there'll be bad people. And if the good people sit on the side and say, we shouldn't do this, we shouldn't do that, well, guess what? The bad people are going to be doing it all the way, right? So the question right now is how software engineering can play an important role here. Because, to be honest, for the first time, in my opinion, I believe that trustworthiness and safety is becoming much, much more important, and it's much, much wider. So there are businesses in the past, like car systems. So somebody tell me, why should I do a degree in software engineering, and why should I do a degree in computer science? Oh, if you want to do cars and this type of stuff, you should do this. But if you do computer science, you can just going to code, right? But more and more, that computer science degree versus a software engineering degree, I think more and more people really need to learn about what software engineering's think and what keeps them up at night. Software engineers don't really think about loops and equations and functions, right? They think about that piece of code, I'm going to be stuck forever. They think about the safety. They think all these bigger things that computer sciences don't really spend as much time on, right? Good. Any other questions? Oh, go ahead, please.
Thank you for the presentation. So for the software development process,
Yeah.
as we know, it's change as new technology evolves, such as waterfall, agile, and DevOps. So in terms of AIware, there are a lot of new stuffs, including the prompt, agent, and like code generation tool. So what do you think about the change for the software development process in terms of AIware?
Well, so it's kind of similar to, I guess Sam Altman's view, right? So it's not really about the size of the foundational model. It's about actually how the agents can collaborate, how they can learn, how they can evolve, how they can coordinate. So I think that's one thing. Second, as I said, the whole requirement engineering and specifying systems. Okay? I've been thinking more about this lately, and I almost think, so when you look at car software, right, and you have level 1, 2, level 3, level 5, right, I think eventually we're going to have level 1 up to level 5 to all different types of software. And what will happen is, and this is the key point, is not like either you are AIware or you're not AIware, right? Instead, there will be these features from the characteristics of the features are very friendly to become AIware. There's a lot of potentials. These ones will not. So a lot of people ask the questions like, it's not a black and white thing, right? And we've already done that before. Some features have, AI models behind them, and some of them have code behind them. And even when even 10, 15 years from now, I believe there will still be some classical code where, for example, device drivers, that just might still remain low-level codeware, but it be supported with, SE for, like a foundational model for SE to generate the code because it's so redundant. Okay, so it's going to be a mixture of both.
Hi. So I'm thinking about in the software production and the software consumers, can be integrated, together. So currently we're talking about the AIware and whatever. So that's more like for the code generation, right? So I'm thinking about a situation, and we will include the end user, the customers, in the software engineering life cycle. So we can imagine a scenario, and when a user is using a software, and so the software will get the statistics of the user and his habit, something like that, and also the user can request some requirements, and then in software engineering we call that maybe AI software engineering, and can generate a special release, for that end user. That means from very beginning, and we include the end user to the software engineering, those kind of life cycle, and So, and this is I'm thinking about. So the question is how the FM, those kind of modules, is it possible to support this kind of imagination? Thank you.
So just to clarify, so you're basically asking how end users can be integrated in foundational model type of software? And
yes.
Okay.
Yeah.
So I'll give you two very, very concrete examples. So today, anybody that will produce a foundational model will have a very hard time competing with OpenAI. It's not because OpenAI is 10 times smarter than this person. But here's the thing. You can hire two people. You can hire a guy that went to MIT, and you can hire a guy just graduated fresh out of MIT, top of his class, Or you can hire a person that just went to high school and spent the last 20 years working in industry. Who would you hire? You most likely, at least I hope so, you're going to hire the person with 20 years of experience because that person knows a lot about the field. And he knows about, he has all this, what do you call it, this blood on his hands and all the sweat, right? And this is exactly the situation. So the problem right now is every day OpenAI is running. Every day somebody's using the chat GPT. The amount of data it's getting is making it better and better and better. So it's, there's the base and there's the input from the users. And we know people got excited and started feeling GPT was exciting because we brought input people. Now, you bring in the world input. So that's kind of, a challenge, and we've seen that already. Second, even when you look at Tesla. So Tesla has this whole shadow releasing technology, right? So Tesla's biggest advantage is that it has thousands of testers live. Okay, but what it's doing all that testing shadow in parallel. Okay, and I guess a year and a half ago, somebody as well kind of opened up Copilot and tried to reverse engineering, and what we found is as well, Copilot is doing actually its own shadow deployment. So what example Copilot does? So you're using it and you think, okay, I'm using it, it's going to complete that piece of code for me. But actually, in addition to that, when you're not asking it to do anything, it's basically randomly practicing. So what it does, it randomly picks part of your code, and it actually assumes, let's assume the developer asked me a question here. And then it gives this answer, compares this answer, and it's learning on the side. And that's what I mean about these gyms, like, top athletes, they practice hours and hours just by themselves. And this type of software, the way to design software that just wants to make itself better, is a totally different way that we have never thought of how to build software.
Yeah, great, thanks.
Yeah, thanks. Okay, so I think if there's no other questions, so thank you for your attention, and I hope it was exciting stuff. So what's going to happen is